equals false, semicolon. So a Boolean in Java can have one or two values. It can either be true or it can be false. So what would be a practical example of using a Boolean in a program? Well, let's just say you wanted to know whether a particular customer was over the age of 21 or not. We might create a Boolean like this. Boolean is customer over 21 equals true, semicolon. You can see what I've done there. The variable name is a question. Is the customer over 21? And we've assigned the value of true to that, meaning that in this particular case, the customer is over 21. Developers will often use the word is as a prefix for a Boolean variable name. This creates a name that seems to ask a question, which makes reading the code more intuitive. But other prefixes can be just as valid. Here are some example Boolean variable names, such as is married and has children, that clearly define what condition is being tested. As we move through the course, I'll show you common and best practices for naming variables, classes, and methods. In terms of the Boolean, you'll see practical applications for this primitive type once we start tackling conditional logic. So at this point in the course, we've covered all of Java's primitive data types. In the next video, we'll do a quick recap of these types, then we'll move from just using string literals, like our simple hello world example, to using string variables. Let's move on now to the next video. In the previous video, we looked at the char and also the Boolean types, which were Java's 7th and 8th data types. At this point, you should be familiar with all 8 of Java's primitive types. You've seen a similar slide before, and I'll show it again here. In review, the 8 primitive types that we worked on previously were the byte, the short, the int, the long, the float, the double, the char, and the Boolean. Each of these primitive types, as I've discussed in previous videos, has got its own size and is used for different purposes. The byte, as we found out, can only hold a number in the range of -128 to +127. It's entirely possible that you'll go for years as a Java developer and not even need to use the byte ever. The most common primitive types you'll use will be an int, a double, and a Boolean, and you'll probably from time to time need to use a long and a char, but not as often. The short, float, and byte data types are rarely used, if at all. As you get more experienced in Java, you'll learn to use the right primitive type for a given computing problem, and that's actually all part of becoming a programmer. So just to reiterate, those are the 8 data types we've looked at, all primitive types built into the Java programming language. As we go through the course further, you'll find that there's a way to create your own data types, which in Java are called classes. This slide demonstrates that most Java programs use some combination of the data types shown in this diagram. You'll use Java's primitive data types, Java's built-in classes, and probably some combination of your own custom classes and classes created by other people. You've already been introduced briefly to a few of Java's built-in classes. These were the wrapper classes, and you may remember I mentioned Big Decimal as a better alternative to floating point primitives when working with currency. I've also said that classes are special data types that can provide extra functionality, like the wrapper classes that contain more information than a simple primitive type. What's interesting about classes is that you can combine data types like maybe one or more ints, doubles, booleans, etc., and create a sort of super data type, which again are called classes in Java. There's an entire section in this course on classes, so I'm not going to go into more detail about them here, except as it relates to the next type on our list, the string. The string is a data type in Java which is not a primitive type, as this slide clearly shows. It's actually a class, but it enjoys a bit of favoritism in Java to make it easier to use than a regular class. In other words, it's treated a little bit differently, and you can use it in ways you wouldn't normally for most other classes. So what is a string? A string is a class that contains a sequence of characters. If you recall, in the case of the char primitive type, it can contain only a single character, either a regular character or a Unicode character. A string, on the other hand, can contain a whole set of characters, in fact a large number of characters. It's technically only limited by the amount of memory space or heap space in your computer, which turns out to be the max underscore value of an int. And if you recall, when we were looking at ints, that maximum size is around 2.14 billion. So that's a heck of a lot of characters that could potentially fit in a string. Let's jump back into JShell and take a look at how to use a string. String with a capital S, my string equals, double quote, this is a string, double quote, semicolon. Note that I typed string with a capital S. It won't work unless you do that. As you can see, a string is very much like a primitive type in terms of how we use it, meaning we can just assign a string literal to it. Let's go ahead and print out our new string variable. But let's preface the string with a little descriptive message. I'll use system.out.print, left parentheses, double quote, my string is equal to, space, double quote, my string, right parentheses, semicolon. So here you can see we can also output a string literal and a string variable by using the plus operator. In fact, you may remember we did something similar when printing string literals and other variables in one statement. You can also do something similar using the plus operator when assigning an expression to a string variable. So let's do that now. My string equals my string plus double quote, comma, space, and this is more full stop, double quote, semicolon. Let's print that out again by scrolling back through our JShell history and using the system.out.print statement we used previously. You can see that by using the plus operator, we get a result that is the original string plus the text we specified after the plus sign. When the plus operator follows a string, it's technically called the concatenation operator because the text that follows it is concatenated to the previous text and returned as a result of that operation. And we can see from the output that my string is now equal to the full text, this is a string, and this is more. You can also use Unicode characters with strings. So let's test this out and add a $ using a Unicode character. I've already looked up the Unicode character for a $ using the website I discussed in the previous video. The Unicode value for the $ is 0024. I'll set my string to the text. I wish I had $1 million using a Unicode character for the $. I could have simply typed in the $ character instead of using the Unicode value, but there are times when symbols aren't available on your keyboard and you'll want to look up their Unicode value and use them like we have here. This string looked a bit confusing because it was hard to see where the Unicode value ended and the numeric value 1 million started. I did it this way because I didn't want a space between the $ and the dollar amount. So you can see that string has got some versatility. We can use a combination of Unicode characters and regular characters. Unlike the char data type, we can actually have a significant number of characters. All right, let's try something different now. There is a way in JShell to run a couple of lines of code, multiple statements, all at once, without declaring them on the same line. To execute multiple lines of code as a set, in JShell, first start with a left curly brace and press enter. JShell will display an alternate prompt, as you can see, 3 dots and a greater than sign. You can add a statement and press enter until you've added as many statements as you want to run. Finally, add the right curly brace, noting that a semicolon is not required after this brace. Once you press enter after the closing brace, all of your statements will run in the order you put them. So let's do that here. First, we enter a single left curly brace and press enter. I'll define a string called numberString and assign it the string literal value 250.55 and hit enter. I'll append a literal string to numberString by typing numberString equals numberString plus double quote 49.45 double quote and hit enter. Finally, I'll print out numberString. Pausing here, we can see we created 3 statements, each ending in a semicolon. When we do finally type in the right curly brace, these 3 statements will be executed in order. This is similar to typing them on the same line. However, when we execute code this way, JShell won't print the value out of each statement, like in the examples above. Instead, it just prints whatever we put in system.out.print statements. This is how a code editor works, and you will see in the next section when we start using IntelliJ. Before we add the closing brace and execute it, what do you think the result will be? Will the 2 numbers be added together? In other words, if our math is correct and we are adding 250.55 and 49.45, the result should be 300. What do you think? Will we see 300 in the output? Let's find out. I'll add a right curly brace ending this group of 3 statements and press enter, which then executes them. Now we see that in fact we don't get the number 300 at all. Instead we've got the 250.55, and after that we've got 49.45. Before I talk about why that happened, I want to enter those three statements on a single line. I'm typing the same three statements as before, but on a single line. So we got the final system.out.print statement with the same result, but you'll see, as we've seen in all the videos to date, that the variable values were output for the first two statements. This is behavior that is specific to JShell. There are two ways to execute multiple statements in JShell: put your statements on a single line, or enclose your statements in a set of curly braces. This shows two ways to execute multiple statements in JShell. Both ultimately give you the same result, but if you want each statement to output its value, then list them on the same line in JShell. If you want to emulate a Java program which will only print what you put in the system.out.print statements, then group your statements between beginning and ending braces. Okay, so that's another JShell hint for you, but let's talk about this weird and unexpected result. So what exactly happened here? Well, in fact, technically the 49.45 was added to 250.55, but it was added as a string. It was concatenated, in other words, in the same way we saw previously with the text strings we looked at. This occurred because we're not using a numeric type, such as an int or a long, or even a double for that matter. We're using a text data type, a string in this case, and a string treats the text or digits in the double quotes as text and only text. In general, when you type something inside double quotes, Java by default interprets that to be a string literal. So there's no numerical calculations done. We'll need to convert that to another type or save it in another type in order to be able to perform mathematical calculations to numbers in a string. In fact, let's look at this in a slightly different way. Let's declare a new int, but we will add a little twist to it. Int, my int equals double quote 10 double quote semicolon. In this case, you can see that while we're declaring an int variable here, we put the value 10 in double quotes. Java interprets that as a string and throws an error, similar to some of the errors we've seen in the past regarding data type incompatibility. Later in the course, I'll show you how you can convert what you think is a number from a string to a number data type. But for now, anything you type into a string is a string, and you can see it's treated differently to the numeric data types that we saw previously. All right, there is another thing I want to show you that might surprise you. Let's declare a couple more variables, one string and one int. I'll assign a string called lastString, the value of 10, and the value of an int, myInt, to be 50. So we have two new variables, one a string and the other an int. Now let's try to add those two new variables together. LastString equals lastString plus myInt. Notice that what we are actually adding is a numeric data type of int to a string. What do you think is going to happen when this is executed? What output are we going to see? Will Java throw an error? Let's execute it and see what we get. You can see there that lastString is now equal to 1050. So even though we've used an integer data type now, in the second part of the expression, we've still ended up concatenating the integer to the string value 10. Our string variable lastString is still configured and set up as a string. In Java, the plus symbol is an operator which can mean addition if used for numbers, but it also means concatenation when applied to a string. A string plus anything else gives us a string as a result, concatenating anything after the string as text to the initial string. So keeping that in mind, Java is smart enough here to say, okay, I know that the integer you've defined, myInt, is actually an integer, but I also know that you're trying to add it to a string, and of course lastString was in fact declared as a string. What Java does in this case is it actually looks at the contents of myInt and converts the value 50 in this case to a string, and then this is concatenated to the string value 10, and that's why we're seeing 1050 as the value of our last string. So myInt isn't treated as a number in the true sense, rather it's treated purely as text by the computer here because it knows it's being added to the string lastString. So the myInt variable itself is still an integer variable with an integer value, but because it's being added to a string, the value is treated as a string. And we can continue on with this example. Let's do something similar with a double. I'll define a double called double number with the value 120.47 and then add that to lastString. You can see here last string is now equal to 1050 120.47. So the text value of our double got appended to it. The behavior was exactly the same as when we used an integer. Java treated the double value as text and appended that as text to our string variable. What we're doing here is only a very elementary way of dealing with strings and adding to strings. In later lessons, we're going to look at more advanced features of a string because we can do all sorts of things with a string. Using strings and manipulating strings will be something you do in every program you write, so the string class and its features are important to know. A string is different from many other classes because the sequence of characters in the string are immutable. What does that mean? Immutable means that you can't change a string after it's created. So in the case of the code we've written, the value 120.47 is technically not appended to the current contents of last string. Instead, a new string is created automatically by Java. The new string consists of the previous value of last string, plus a textual representation of the double value 120.47. The net result is that our variable last string has the concatenated value. However, Java created a new string in the process, and the old one will get discarded from memory automatically. Now, don't worry if that makes no sense at this time. It will later in the course. For now, I just wanted to point out that strings are immutable, and that will make more sense and become more important as we progress. Because of this, the code that we just wrote there was quite inefficient. Because a new string gets created for every operation, appending values like this is inefficient and generally not recommended. Java provides another class that is more efficient if you are doing a lot of appending of multiple strings or values. The string class is immutable but can be used much like a primitive data type. The string builder class is mutable, meaning it can be changed but does not share the string's special features, such as being able to assign it a string literal or use the plus operator on it. Both are classes, but the string class is in a special category in the Java language. Java provides the string builder class in its library to address the inefficiency of the immutable string when you are creating a large amount of text from many smaller parts. As mentioned, unlike a string, the sequence of characters in a string builder class can be changed. We'll be revisiting the string and the string builder classes in much greater detail after we develop a better understanding of how classes work in Java. But I've also shown you the string concatenation operator today because you'll come across code written in the style we've used in this lecture. Using operators like plus to concatenate string values is code you'll probably see. It's useful for you to know how to do things this way, but it's also important to understand there's a better way to do it, so stay tuned for more on strings and string builders in future videos.